Track 15, which is Advances in Vertical Transport, Part 1. Before we start, I'd like to just give a very small introduction about myself. I am Krishan Khanna. I'm the chairman of a high technology company called I2K Solutions. We're into artificial intelligence and education. And now I would request our second speaker, Mr. John Mizon of Schindler, to give his presentation.
Thanks very much. The word that's come into my head the most is opportunity. And what an opportunity there is in this city of Mumbai, an opportunity to change the lives for the better of millions of people. And a real challenge to all of us in all these industries, and particularly perhaps a challenge to us in the elevator industry. And you know, one of the things we've done in the elevator industry is we have risen to challenges. That's what we've done throughout the history of our various companies around the globe. And it started where the challenge was just build tall buildings at all. We just have to build tall buildings. And then people wanted much more efficient tall buildings. And, you know, Johannes made the point of how important it is to have certain service levels. And when you build higher, you have to achieve those without getting a huge core size that makes the building unviable. So that's very important. And we started with these extraordinary electromechanical controls, and we did extraordinary things with them. And then as buildings got taller, fortunately, technology came along with microprocessor controls, and we could get performance higher and higher. And through the 50s to the 90s, it was sort of a golden age in the industry. Everyone was competing to get that better level of performance to enable us to build taller and more exciting buildings. And then we reached a sort of a plateau. And we reached a plateau because however good the technology was, the techniques were fundamentally getting out of date. So we'd gone from this great era of possibility where, boy, we can build tall buildings, this is great, to really now struggling with the viability of the buildings. And naturally, as the millennium end was approaching, this was becoming harder and harder. And when you're in a conference like this and you hear these challenges of building not just apartment buildings, but buildings where people may work and have all the other infrastructures of life within them, these challenges are going to get greater still. Now, to meet these challenges at the end of the millennium, we started to look at an idea that had been around for a very long time. When you think about it, getting in an elevator and telling people where you want to go makes no fundamental sense. Imagine if you got in an aeroplane and you said to the pilot, I'd like to go to London. The guy next to you, I'd like to go to Rome. The guy next to you, I'd like to go to Sydney. Okay, I'll drop you and drop you and drop you. What a terrible use of that airplane equipment it would be. But that's what we've done traditionally in elevators. And it was always realized that if instead of that, we knew ahead of time where people wanted to go, we could get elevators back down to the ground floor much quicker, empty elevators, and we could get much better service from that piece of equipment. The problem is, and obviously most of you in the room are much too young to remember these times, but back in the 70s when this was first talked about, first of all, the computers were much too old, much too poor in terms of performance and high in cost to make it work. But secondly, the one that people always forget is that we didn't know how to talk to machines. Today we have our iPods, we have our laptops, we converse with machines on a daily basis all the time. In those days we just didn't talk to machinery, so it wouldn't work. But about 20 years later we got the high volume, low cost chips that we needed to make this sort of technology viable, and we all knew how to talk to machines. So what that meant was, in the early 90s, the first generation of these destination control systems where we could actually find out ahead of time where we needed to go, started to become a reality. And these systems featured a keypad outside of the elevator. You'd tell the elevator where you wanted to go. The system would tell you which car to take. When the car arrived, it would give you a little reassurance that, yes, this is where I would like to go. Yes, I should get into this cabin. And that was the first generation systems that enabled us to build buildings that we would not have been able to build with conventional control. And we would make these little diagrams with dots to show that we now knew a piece of information about our passengers ahead of time. But we soon realized a couple of things that will be obvious to most of you. One is we live in a three-dimensional world, and secondly, it's populated by human beings and not by dots. And human beings have a lot of other needs. And it was meeting those other needs that brought us to our second generation of system. Here we took that keypad and we added a card reader. Now with that card reader, what ends up happening is you know a lot more personal information about people. For example, in a building that's multi-use, you may need to know that they have a security clearance to go to, say, the school or the medical center or something like that. And counterintuitively, but I promise you in examples all over the world we can show that, the more personal service you can give, in fact, the better overall efficiency of the building. And this will be particularly important in the multi-use infrastructure buildings that we've been talking about putting into Mumbai and other cities in this great country over the last couple of days. So you bring in a whole lot of new features when you can actually show a little bit more about what you need to the elevator system. And the only one I'm really going to pick up is what I call dispatching. And this terminology really goes right back to what my colleague was saying about the issue of getting the best possible performance from a group of elevators. Because obviously once you've got this expensive equipment, it's important, critical, that it performs as well as possible. And in these second generation dispatchers, just like with the up and down buttons, you can have a very sophisticated controller or you can have a very mundane, somewhat old-fashioned controller. Here with the second generation dispatchers, it's key to study all the buildings you've already installed and understand what happens when people move through them, what the traffic looks like, how the people react to various things. And when you do that, you can actually make a very sophisticated way of determining who should get into which cabin, and that in turn will give you much better performance in the building. It's a bit like playing a computer at chess. What happens when we play a computer at chess? Well, what happens is the computer is not very bright. You use your tactics and your expertise. It uses dumb processing power. So you make a move, it calculates every single move it could make, then every single move you could make, every single move it will make. The problem is that after about 3 levels down, you're into trillions of calculations and the computer can't cope. With the elevator problem, it's essentially the same thing. If we put in a call to a destination control system, say to floor 5, and I've got now a vector here because I know the starting point, I know the ending point. What I really want to do is look at all the other calls in the system, and then what I want to do is consider that new call with all the other calls and determine which elevator should serve the new call to optimize the entire call service. And if you can get to the end of that entire process, which a chess program can't, but we can, then you always get optimal service and you can get very high levels of performance. So now I want to talk to you about a new level of system we call third generation systems. And third generation systems builds on this notion that the more details you know about what you need to do for somebody, the better and more efficient the system can be. And further, if you have a multi-use building with its infrastructure enclosed, the things that you will have to talk to the system about are going to be more complex because you're going to be wanting to do more complex things. And in these buildings of the future, our challenge is to look at that entire question, not just the vertical transportation, but what we call transit management. And I've defined transit management as the design discipline allowing authorized personnel to move seamlessly into, out of, within a given facility with the appropriate security and transportation systems so that their journeys have the levels of security and safety necessary for their welfare while maximizing the level of comfort and convenience for them individually. And in these type of buildings, up and down won't be enough. It's going to be the entire building movement that's going to be important. If I live and work and go to the doctor and go to my school in the same building or complex of buildings, coordinating that entire effort is going to be absolutely critical, or the buildings frankly won't be buildable because the cores with all the elevators you would need would be much too big. So this is very important. And our futuristic view on this, we call this particular device a port personal occupant requirement terminal. And the notion here is to actually have a conversation with our passengers. A fixture is not a great conversation list. You've pushed me, I've lit up. It's not a great conversation. We want to have a conversation with our passengers and actually find out what their needs are so that we can meet them. And if you open up this thing, it has a lot of interesting technology. It has a touch screen inside it. It's got a microphone, a card reader. It has a people detector because we don't want to be running it when no one's using it. It has a processor, of course. It has a brightness adjustment. It has Bluetooth. And if we turn it around at the back, it has a microphone. So we can talk to it and it can speak back to us. And the notion of this device is that it's ubiquitous throughout a building to provide the guidance that we need when we talk about transit management. It can be on a wall, for example, or it can have its own pillar so that it can stand in a lobby area and is equally accessible. I said it was ubiquitous. We can use it vertically. We can also use it horizontally. And horizontally, it solves perhaps one of the most important but saddest problems we have in the modern world, which is the barrier. Now we have to put turnstiles on our buildings in many occasions. And these things have been design horrors and maintenance horrors over the last 10 years. Why? Because they're a confluence of technology. We get the barrier manufacturer, the security access company. We get the person making the security equipment that goes onto the barrier. If there's a dispatching to the elevator company gets involved. So everyone's getting involved, and it's very, very difficult to maintain these. What we would like to do with something like the port is simply use a port and a barrier and make it a very, very simple interface. And seeing somebody go through like that is a bit quick, which of course we want, but just to be clear what's happening, one of the ports is at one end and is showing its card reader, and then the information which elevator to go through is coming from the port at the other end here. If we're going out, we do exactly the reverse. Here's the card reader, and you get the information, the exit information. But we've taken a transaction that could be quite difficult and made it much simpler. Now, of course, vertical transportation will be an important part of this building and one of the important uses of the ports as we go through what we call the elevator transit part of the journey. Now, these ports can have on them a typical keypad arrangement. And maybe for security personnel that want to go anywhere in the building, that makes a lot of sense. On the other hand, what we'd really like to do if we give personal service is to give a list of destinations that are just important to that person and that person alone. And we can generate that list in several ways. It can be card-driven. I come in, I show my card, there we go into the building. And look at what I've done there. I've taken something that's normally a negative security transaction and I've turned it into a positive. I'm introducing myself to the system so that it can help me as I move through the building. It can be even simpler than that. It can be context-driven. If I'm actually only renting 3 floors of a building and I'm standing on one of them and my only other access is the lobby, then I don't have to worry about knowing what needs to be on this list. And when I approach it, it immediately makes sense to me. It's a simple entry. Another idea is to make it predictive. During the day, I'm using the system, and the system's recording the things that I'm doing with it, which floors I like to go to, what's my journey pattern, so that when I come at a specific time of day, the system knows already what my likely requirements are going to be, and it can build up this database, and then it can give me a list in priority of my requirements so that I know exactly which one I'd like to choose. And choosing that is again something we've tried to think about, because one of the issues we have here is really a lot of people don't like to touch things that 1,000 other people touched before. So now we're thinking to ourselves, well, do they need to touch it? Well, no, they don't. They could just hold their card there, and by holding their card there and taking it away when the scrolling reaches their floor, they've managed to make that transaction with no touch whatsoever. Obviously, this is critically important for blind people. What happens if I have my card and 3 of my friends come along with me? Well, our notion for that is what we call forward credentialing, and I will tell you as the father of a 25-year-old daughter how it works by means of this cautionary tale. Here's Toby, the thrusting young executive. He knows how to work the system. He gets his elevator and he goes inside. But Toby naturally has hormones, and he sees the lovely Marita. She's running for the elevator. He holds the door open for her. In she goes without using her card, and off they go to make each other happy. If only it had a happy ending, but sadly it does not. Because when Marita shows her card at her floor a few minutes later, she gets a nasty shock. She gets a nasty shock because her card is invalid. It was never credentialed to that floor. It was available for a journey from the lobby. It was not available for a journey from that floor and would not be available until the journey from the lobby had been made. So Marita, learning 2 important lessons in life, how to use the elevator system and not to trust handsome young men, goes off and makes her peace with security. If we use a system like that, what it means is we get a lot of advantages, especially in these multi-use buildings where security will be an issue. One of the things we can do is we can build up a real-time population distribution in the building. And we even know what the tolerance is because we know the number of violations that there may end up being. What that means is that the whole issue of evacuation becomes very interesting. Evacuation by elevators is something that's very controversial. In New York, the fire marshal says, "Over my dead body." In London, they're specifying it in some contract. I was talking to a gentleman the other day. He's putting up a building in Oklahoma, and they have tornadoes. He needs to get everybody in the building down in 15 minutes to the tornado shelter, and he knows he can't do it without using the elevators. If you have a system like this that can give you a lot of information, the first thing you can get is real-time cogent information. And it may be as simple as just saying, "Please use the stairs." But because it's on the same device that you were putting a call in a few minutes ago, you know that that's what you must do. And no amount of writing it up on the wall is going to do that for you. But if you know where everybody is in the building, perhaps you can actually do better than that. And let me just show you what I mean. If on this top half of the building, the bottom half you may decide, let them take the stairs, but you decide to use elevators. If on this floor, for example, you know exactly how many people are behind the elevator, you can synchronously bring enough elevators to that floor in order to evacuate everyone at the same time. Tell them the elevators are coming, and then when the elevators are here, tell them they're here, which ones they should use, and you can have a very orderly evacuation. Now, if you bring an elevator holding 20 people to a lobby with 30 people in it, it'll never leave. It'll never leave. It'll be overloaded, the doors will jam, it'll never leave. This way you have an orderly, concise way of evacuating the building. Everyone can see what's going on, and you really can do this very quickly. So it's something to think about, using elevators for evacuation under certain conditions. Unavailability tolerance. What happens when half the elevators in the building go out? Maybe there's a construction project, for example, and you have to take a huge amount of capacity away, and there's lines down the street. You don't want that. If you can communicate people, you can plan around it. And again, go back to this slide here. Why does this system work well? Because you don't have as many stops on the way up. And if you can eliminate those stops, you can do with less elevators. So what happens here when our friend Toby comes up to the port? He gets a message. He gets a message asking him to please walk down 1 flight of stairs to get the elevator, because he's the only person at that moment in time going from or to the system. He's the only person. So please, Toby, walk down. And because he's been briefed by the building management, he knows what's going on, he can do that and there's no problem. And that way we can make do for a brief period with far fewer elevators. And the key is that what happens is this may be the low use floor only for 5 minutes, and these are the higher use floors. 5 minutes later, this may be the higher use floor. So the chances of anybody being asked to walk down are only under simulation we've calculated once or twice a week. The impact on the building is extraordinarily significant. I'd like to talk about something very close to the heart of this industry, which is the handling of disabled people. And we put a lot of thought into this, and a lot of times with an elevator system, you get a button that says disabled use. And talking to disabled people, talking to disabled people, you know, they don't want to have disabled use. They want to have use with everybody else. This system, because it's a personalized system, the card contains all the information you need. This gentleman needs a little extra time to get to the elevator. He needs a little extra room when he's inside it. If he was blind, he might only want to use elevator D because that's the one he can find. All these things have been taken care of. It's a big step. It's a small footprint. We must look at energy, and systems like this can enable us to, for example, take a system that's using huge amounts of energy running around the building to give extraordinarily low waiting times, raise those just a little bit, and I'm talking from 5 seconds to maybe 15, use less elevators during that low traffic period, and essentially get very significant energy savings. And, you know, in conclusion, when we talk about all this green stuff, we kind of put these things into green environments and it kind of makes us feel good, and woodland and it's green and it's all nice. But let's never forget that that's not the situation we're in. We're in the urban environment, and we're in the environment where we're reinventing the urban environment, especially in cities like Mumbai. This must be reinvented. And with technologies like this, we can reinvent the urban environment. And technologies like this, and I don't know if Jim Fortune's in the room. I know he's speaking later today. But Jim wrote a seminal paper a few years ago where he pointed out if you take a double-deck elevator and you match that up with technology such as these destination control systems, you can get much smaller cores. You can make buildings like we need to build in Mumbai and elsewhere possible. And this is really a tremendous step forward. So let's get back into our elevator time machine and go into that most exciting place, the future. And again, you can't come to a conference like this without being tremendously excited about the future of this city and this country. And my message to everybody designing buildings is come to our industry early and often. Come early and often, because we may have solutions that can make you rethink your visions. Maybe things you thought were not possible in the future really are possible today. And if we do that, if we work together, bringing these new technologies, I believe we can transform this city to have a wonderful tomorrow. And I thank you very much.